This is a demonstration I did for exploring how rotations work with each other. The link to this demo will be in the description. There's a finer range which controls how far the sliders end up going, and there's an extended range under advanced, so that we can get much longer sliders. Now, what happens is this is the origin. This is a rotation vector, and that's the vector around which this has been rotated by 180 some degrees, actually, to get to where it is. A more normal rotation might be like here. So this vector from the origin to this point represents this rotation. Another rotation on the second plane here ends up being another vector from that point. But basically still from the origin to this point is what the final resulting vector is. But what we end up with is these three loops that for a rotation around this is set up as yaw, roll, yaw, and pitch, that they will follow these different curves. So as each one is selected, this is the curve that applies to that slider. And my current position is here. So if I rotated 360 degrees around that curve, I would end up at this point. And this is the same orientation. So we go from 251 to like, I don't know, 13 something. So now that's the same orientation of this inner plane that it was at. It's 180. No, basically here. So it's rotated 360 degrees, and its resulting rotation vector is not the same as where it started. It's now here, but this is the same resulting orientation. That if you apply the resulting rotation matrix of this at one tick, it rotates into this configuration. So you end up with two non-identical locations where the orientation is the same, but the rotation vector that represents that is entirely different. So what happens is you end up always having to rotate 360 degrees, 720 degrees, in order to get all the way around the curve, to get back to your original position. So since these are not identical rotation points, in the case of electrons that are spin 1/2, if they exist at this rotation point, and you rotate them 360 degrees, then they're out of phase with their original representation. So they interfere with each other, and you get destructive interference. Although, if you rotated another 360 degrees, then you get back so that the electrons are in the same phase with the same rotation vector. So part of this is really just the math, that when you rotate a rotation, because these are controlling the rotation of the matrix, the rotation of the rotation vector that represents the position or the orientation of that frame.